Assalamu alaikum wa rahmatullahi wa barakatuh. Dear student, I hope you are doing very well. Today we are going to complete tutorial sheet number 2, which is part of high voltage engineering. So today we are gonna solve 3 questions from this tutorial. So which is the question 3 and question 4 and question 5. So in the beginning, I want to let you know that you have to bring your note and your calculator to practice doing calculation with me, and your note to write any doubt that you have, because I will start reading question 3 and answer question 3, then I will read question 4 and answer question 4, and in the end I will read question 5 and solve question 5. And in the end of this class, I will give you a time to ask any question that you have doubt in. So if you have any problem in question 3 or question 4 during the explanation, you have to write it in your note, and in the end of this class, I will give you a time to ask all your questions. Okay, so let's begin reading and solving question 3. So in this question, in question 3, he asked us to draw 3 stages Cockcroft-Walton voltage multiplier generation circuit. So he wants us to derive the equation of the optimum number of stages to produce maximum output DC voltage. Define each symbol used. Okay, so here let's move on to the answer sheet to show you the drawing of the three stages. So this is the Cockcroft-Walton multiplier generation circuit. So it will be look like this. So this is a three-stage system. Each stage has 2 diodes. One will work negative and the second one will work positive. So each stage, this is first stage, this is the second stage, and this the third stage. So each stage have 2 diodes. One diode 1, diode 2, this for stage 1, diode 3 and diode 4 for stage 2, and diode 2 n minus 1 and diode 2 n, this diode 1 and diode 2 in stage 3. So as I said before, each stage has 2 diodes. One will work negative and the second one will work positive. And this will be explained by the theory doctor on the lecture this week, and you will understand this more with the doctor. Okay, so this is the formula for a 3-stage Cockcroft-Walton generation circuit. So V output is equal to N V max minus I, which is the current, load current, divided by FC, F, which is the frequency, and C, which is the capacitance. So then open the bracket, 2N squared divided by 3. 2N to the power 3 divided by 3 plus N squared divided by 2 minus N divided by 6, and close the bracket, minus I, which is the load current, divided by frequency into the capacitor, open the bracket, N, open the bracket, N plus 1 divided by 4, and this here is the formula when N is less than 5. So if you have the number of stages less than 5, you can use this formula to solve your question. So for N greater than 5, if N bigger or greater than 5, the number of stages is bigger than 5, we can neglect N squared and N compared to N to the power 3. So if N greater than 5, we will use this formula, which is 2N Vmax minus I, the load current, divided by the frequency into the capacitor, into 2 divided by 3 into n to the power 3. This is only if the number of stage is greater than 5. So we have two formula here in this circuit, in Cockcroft-Walton circuit. So if the number of stages is less than 5, we will use the long formula. If the number of stages above 5, so we will use this formula here. So now for optimum n, we can derive this. So dV max divided by dN, which will be equal to V max minus I divided by Fc into 3 divided by 3 into 3n to the power 3. So we derive this and we get this, we derive the formula, this formula here, and we got this, this equation here. So 3n squared. Okay, I think all of you know how to derive, how to use the derivation. So here will be the 3n here will go with the 3, which is divided, 2 divided by 3 will go, the 3 here will go with the 3n. So the equation will be like this: 2V max minus I divided by frequency into the capacitor into 2n square will be equal 0. So now to find the number, the optimum n, we will move this side to after the equal. So 2V max will be equal I divided by Fc into 2n square. So here to find the value of n square will be V max into frequency into the capacitor dividing by I, which is the load current. How we get this? We divide this by 2 and divide this side by 2 to move this to here. Okay, guys? So we divide the both side by 2 to remove the 2V max and to remove the 2n. So we get this formula here. So n optimum will be equal in optimum. So here is square. We have to neglect the square here. So n optimum will be equal root V max into Fc divided by the current I. And this is the formula to find the n optimum. This is how we find this formula to get the n optimum. Okay, so now we finish this question, which is question 3. If you have any doubt in this question, just write in your note, and in the end of the class ask me about your doubt. Okay, now I will move on to the question 4 to read the question 4 and solve it. So here, question 4, he said, a 10 stages Cockcroft-Walton voltage multiplier has all capacitor of 0.06 microfarad. The secondary voltage of high voltage transformer is 100 divided by root 2 kilovolt with frequency of 150 hertz. If the load current is 1 milliampere, determine the voltage regulation, the ripple voltage, and optimum number of stages for maximum output voltage and the maximum output voltage. So in this question, he gives us some giving values, and he wants us to find this required here. So let's move on to the required that he asked us to do. Okay, so let's move on to the question 4. So the giving value n, he gives us the number of stages is equal 10, and the capacitor, he gives us the capacitors 0.06 microfarad, and he gives us the volt, which is equal 100 divided by root 2 kilovolt. To find Vmax, we have to multiply it by root 2. So 100 divided by root 2 into root 2 will give us 100 kilovolt, because root 2 will go with this root 2 here. Okay, and the frequency as it is giving in the question 150 hertz, and the current as it is giving in the question 1 milliampere. Okay, so the first require in this question is voltage regulation. The voltage regulation formula is equal delta volt divided by 2n Vmax into 100. Okay, this is here the formula to find the voltage regulation. So since we don't have the delta volt here, we have the value of n, we have the value of Vmax, and we don't have the value of delta volt. So we have to find delta volt. Here, since the number of stages is greater than 5, we will use this formula. So delta voltage, which is a voltage drop, it's equal I divided by Fc into 2 divided by 3 into n to the power 3. Okay, so by substituting the value of I here, I it's equal 1 into 10 to the power minus 3, and the frequency is 150 into the capacitor, which is 0.06 into 10 to the power minus 6. Okay, so then we open the bracket, 2 divided by 3 into the number of stages, which is 10 into the power 3. So if you use your calculator, you will get this value here, which is 74,074.07 volt, and we change it to kilovolts. So delta volt, the voltage drop will be equal 74.07 kilovolt. And now, since we got the value of delta voltage, we can easily use this formula and only substitute the value in this formula and get the voltage regulation that is required. So by substituting the value to get the voltage regulation, so here the delta volt, which is 74,074.07 divided by 2 into 10, which 2 is the number 2, and 10, which is the number of stages, into Vmax, which is 100 into 10 to the power 3. And all this is multiplication by 100. So we will get this answer 3.70%. So the voltage regulation will be 3.70%. Now let's move on to the second required in this question. The second required in this question is ripple voltage. The ripple voltage for Cockcroft-Walton generation circuit will be equal I divided by Fc, open the bracket, n plus 1 divided by 4. So here all the value that we have it here in this equation. So only we need to substitute the value. We only need to substitute the value and calculate it and get the answer of the ripple voltage. So I, as it is given in the question, it's 1 into 10 to the power minus 3 divided by 150 into 0.6 into 10 to the power minus 6, which is the capacitor. Okay, and open the bracket, the number of stages is 10 into 10 plus 1 divided by 4. So when we use our calculator, we will get this answer, 3055.5 voltage, and we will change it to the kilovolt to make it better. So ripple voltage will be equal 3.05 kilovolt. So the ripple voltage is 3.05 kilovolt. So to find the percentage of the ripple voltage, we will use this formula. So ripple voltage divided by 2n Vmax. 2n Vmax. So into 100. So the ripple voltage we got 3055.5 divided by 2 into 10, 2 into 10 into 100 into 10 to the power 3. All this is multiplication by 100 will give us 0.15%. So the percentage of ripple voltage is 0.15% or 0.152%. So now we solve the second required of this question. Now let's move on to the third required in this question. So the N optimum, we just explain how this formula, how we derive this formula. So root 2, okay, Vmax into Fc divided by I. Vmax, we know the value of Vmax. Also, we know the value of the frequency. Also, we know the value of the capacitor and the current. So only we need to substitute the value to get the N optimum. So the value of Vmax is 100 into 10 to the power 3 because it's kilovolt, okay, and into the frequency, which is 150, also into the capacitor, which is 0.06 into 10 to the power minus 6, divided by the current, which is 1 into 10 to the power minus 3. And if you use your calculator, you will get the answer as 30. So the N optimum is 30. Okay. Now let's move on to the fourth required in this question. He asked us to determine the output DC voltage. So the formula for the output DC voltage, it's equal N optimum into 4 divided by 3 into Vmax. So all the value that is given. This is the formula that we have to use it to find the DC voltage. So N optimum is, we got it as 30 into 4 divided by 3 into the Vmax, which is 100 kilovolt. And if you use your calculator, you will get as 4 million volt. So we will change it to kilovolt. It will be 4,000 kilovolt. And this is the end of question 4. So all thing here, all what we need here only to substitute the value. Only the first part of this question we have to find delta voltage to find the voltage regulation. So everything here you have to know the formula and substitute the value to get the answer, and you will have full understanding after you take the theory part with Dr. Abdulaziz this week, inshallah. Okay, let's move on to the last question in this class. So let's read this question first, and then I will start answer the question. Okay, so question 5 here. A triple stage DC voltage cascade rectifier of Cockcroft-Walton type is supplied by high voltage transformer of secondary voltage of 150 kilovolt at frequency of 50 Hz. If the unit capacitance is 0.04 microfarad, he wants us to calculate the optimum number of stages to obtain maximum output high voltage DC when load current is 6.12 milliampere he wants us, when we find the number of stages in optimum, which is the number of stages in this question, determine the ripple voltage, percentage ripple, and the output DC voltage corresponding to this optimum number of stages. So he wants us to use optimum number of stages as a number of stages. Okay, let's move on to the answer sheet. Okay, so question 5. Question 5. So here I make a mistake. N it's equal 3. Here n it's equal 3. This is, we will neglect n equal 3 because he asked us in the question to use n optimum as a number of stages. Okay, so V it's equal 150 kilovolt. Okay, and to find V max, we have to multiply 150 volt to root 2 to make it as a V max. So V max is equal 150 into root 2, which will be equal to 112.13 kilovolt. The frequency it's giving in the question as a 50 hertz, and the capacitor is equal 0.04 microfarad, and the current, he give us the load current as a 6.12 milliampere. So the first require in this question, he asked us to find N optimum. N optimum, as I said, you have only to know the formula. The formula for N optimum is V max into FC divided by I. So V max, we have it here in the question, it's giving, and the frequency also it's giving in the question. The capacitor also it's giving in the question, and the load current it's also giving in the question. So we need to substitute the value for V max, which is 212.13 into 10 to the power 3 because of kilovolt, okay, into F, the frequency, which is 50, into the capacitor, which is 0.04 microfarad, which will be 0.04 into 10 to the power minus 6, and divided by I, which is 6.12 into 10 to the power minus 3, because the value here is by milliampere, we change it to ampere. Okay, so if you use your calculator, you will get the number as 8.32, and we will make it as a 9 because it's greater than 8. We cannot use 8, we will use number above 8. Okay, so the number of stages here we get as 9. So this is the number of stages in this question. So ripple voltage, it will be I divided by FC into N plus 1 divided by 4. So we only need to substitute the value of the current I, which is 6.12 into 10 to the power minus 3, divided by the frequency, which is 50, into 0.04 into 10 to the power minus 6, which is the capacitor here, and open the bracket. The number of stages is 9, as we find it right now. Open the bracket, 9 plus 1 divided by 4. Okay, if you use your calculator, you will get this value, which is 68.85 kilovolt. You will get it by volt, and I change it to a kilovolt. Okay, so if you get it by volt, you will get like 68,850 something. Okay, and you have to change it to kilovolt. If you keep as a volt, it's okay also. So the percentage of ripple voltage is equal 68.85 divided by 2 into N, which is 9, into V max, which is 212.13. Here we neglect kilovolt because the V max is by kilovolt and this by kilovolt, and we delete it together. Okay, into 100. So the percentage will be 1.80%. Okay, everything is clear. Now I will move on to the third required on this question, which is the delta volt. The delta volt, as here, as the number of voltage, the number of stages is greater than 5, we will use this equation, which is the small equation. So I divided by Fc into 2 divided by 3 into n to the power 3. We only have to substitute the value of I here, which is 6.12 into 10 to the power minus 3, the frequency, which is 50, and the capacitor, which is 0.04 into 10 to the power minus 6, and 2 divided by 3 as it is, and the number of stages as 9 into power 3. So if you use your calculator, if you calculate this, you will get this answer, which is 1,487,160 volt. And if you make it as a kilovolt, it will be 1,487.16 kilovolt. Okay, so only you have to know the formula to solve any question. So in this subject, it's depend on the formula, depend on your knowledge in the formula. And the last required in this question is the output DC voltage. Output DC voltage, as the question before, in optimum into 4 divided by 3 into Vmax. So in optimum we get it as a 9, 4 divided by 3 into Vmax, which is 212.13 kilovolt. If you use your calculator, you will get this answer, which is 2545.56 kilovolt. So guys, you will get the full knowledge about this when you attend the lecture with theory doctors. So it will be very easy for you if you attend the theory part. And this is the end of our class today. And if you have any question, just ask me. Thank you so much.